Going here. Let's get into it. I need to start the Blackboard recording, even though I think the Blackboard recordings, when we do the breakout thing, the breakout room thing, it usually trips up the Blackboard recording. So over time, I think that probably YouTube is going to be more reliable. Once again, thanks to everybody who is using the webcams. I appreciate that. It really helps to see a couple of students on the other side of the wire as we go through these classes. Homework number 1 you've just submitted. Again, my sincere apologies for the mistake. I gave you a clue yesterday and I said that what is it, just more than 29,000 or something like that, but then it turned out that what I was looking at was when I was using 8.5% interest. So that hint was probably more of a hindrance than a help. I apologize. That's the last thing you need, is me making it more confusing for you. So I'll endeavor to be a little more precise in the future when I give you hints. So I apologize. Hopefully that didn't cause too much confusion or delay. But homework 1 is submitted. I'm going to turn the grader loose on that assignment immediately, and I think that probably you'll start seeing your grades over the weekend and certainly by next Friday. Which is when homework 2 is due. So homework assignment 2 is available now. If you want to get an early start on that, it's posted on Blackboard, and so it needs to be uploaded as a PDF file. Same approach as before. Upload it to Blackboard before class on Friday, and the PDF file should be black and white, single continuous, one document for the entire assignment. Okay, so any questions before we start talking about compounding? All right. Well, this is section 1.8 in your textbook, and again, just a quick plug. I think your book is really well written. Not every academic textbook is, so take advantage of that fact and rely on the author to explain things in a different point of view, and hopefully that'll improve your understanding beyond just listening to me. All right, well, let's talk about interest now. Simple interest is just what the name would maybe indicate, and if we have some time at the end, I'd be glad to show you the answer to number 3. Simple interest is where compounding doesn't occur, and the amount of the interest is simply the rate multiplied by the number of periods multiplied by the principal. And so the idea with simple interest is that you don't have to pay interest on top of the interest. And what I mean by that will maybe be more clear when we talk about what compound interest actually is. Compound interest is going to be different because you will pay interest on the interest. But just as an illustration for what simple interest is, let's say that a $100,000 loan has been taken out and it's 3 years, the period of the loan, and 10% per year. So the repayment amount is just simply going to be 100,000 times 3, which is the number of periods, and 10% per period. So the interest is 30,000, so the total repayment will be the principal and the interest. And that's called simple, not only just because it's a little bit easier to calculate than if we have compounding interest, but it's simple because you'd have to be simple to give somebody a loan on these terms. It's disadvantageous to you as a lender. So you'll notice that if you go to most banks, they're going to use this other approach, all banks, just to clarify. The only person who'd maybe give you a simple interest may be a family member, somebody who just really likes you, because it's more profitable to charge compound interest, where you're charging interest on top of the interest. So this is simple, which is maybe just an academic definition because you won't encounter it very often, if ever. But compound interest is where the amount of interest you pay each period is dependent on the amount of the loan originally, the principal, plus all of the accrued interest that has occurred up to a certain time. And so the reason why it's called compound interest is because the interest is compounding, meaning getting larger and more significant over time. And so to calculate the interest amount in any particular period, meaning just in a certain year, how much interest is applicable to that year. What you do is you combine the principal amount, all the previous interest, and multiply that by the rate. So this formula that's on the screen now maybe makes it seem a little more complicated than it actually is. Now, I'm not saying the formula is wrong, because this formula is right, but it's not as tricky as this maybe makes it look like. If we're just in words, we were going to dissect this formula. What it says is the interest in a given year, so T means just in a specific time period, so during a certain month or a certain year, whatever the period is defined as. So in that period, the interest amount is the principal of the loan plus all of the previous interest. And so this is saying the interest in previous periods, meaning in all of the time periods up until the previous one. So T minus 1 means last year or last month, the one before this. So all the previous interest, so combine those amounts and multiply it by I. Okay, so let's sequentially go through how you'd calculate compound interest, and it's going to demystify this a little, I think. So this same $100,000, and you're taking a loan for 3 years, 10% per year, but this time compounded annually. So how much do you owe after 3 years? Remember, in our previous example, it was $130,000. So you're going to see why banks prefer this method instead of simple interest, because in simple interest it was only $130,000 they get back. This way a bank is going to get back more, because at the end of the first year you owe them $110,000 because they charge you 10% of the loan balance, which is $100,000. But now at the end of the second year you have to pay 10% of the balance from the previous year. So now in the second year you don't just owe $10,000 in interest, but you owe $11,000 in interest because you owe 10% of the previous year's balance at the end of the period. So at the end of the first year you owed $110,000, which means now in year 2 you have to pay 10% of the last year's balance. So the same trend continues in the third year, where in the third year the interest amount is 10% of the previous year's balance. And so when we combined the $11,000 that applied during year 2 with the previous year's balance of $110,000, that was $121,000. So the interest amount in year 3 is 10% of the $121,000, and in the end, at the conclusion of the 3-year period, when this has been compounding annually, the new balance is $133,100, which means that if the bank compounds annually instead of no compounding, they get an extra $3,100. And you can have a pretty nice meal for $3,100. And so they'll always do compound interest when they get the chance, and that's always. So any questions about how compound interest works, this step-by-step process here? Any questions how we could think of this formula or get to the end result? A question about the homework. Let's move the specific questions about the homework to the end of class, but if you have a question about the concept, I'm glad to answer a concept question, but I'm worried that if we got bogged down in the specific details of a particular question on the assignment, we may not get through the rest of the material. So I'll just ask that we wait on a specific homework question.
So with compounded interest, if you don't pay a certain amount, you can end up paying on the loan forever, correct?
No.
In a way.
Yeah, well, I take your point, because, you know, a lot of people say, like, for example, with a credit card loan, that if you just pay the minimum balance, it feels like you're paying it off forever. But I think that legally it's not possible to originate loans in the United States where the interest is accumulating faster than the payments. I mean, you know, like if you take a loan out from the mob, you know, like how they do in movies, I mean, it's possible that your balance is growing faster than you're paying it off in that kind of a scenario, but there's no bank or credit card I'm aware of where the repayment that they will permit is slower than the interest is accumulating. So Christian had a question, so why are we making j equal to t minus 1? And that just means the previous year's interest. And so let's look at this formula for I sub 3. So in the third year, as an illustration, if we want to know what's the interest amount, it's the principal, so P is 100,000, and then j equals t minus I, that just means all of the previous year's interest. And so the interest when t was equal to 1 is 10,000. The interest when t was equal to 2 is 11,000. And now if j is 3, if we're in the, j would be 2 when t equals 3. So if I equals the third year, which is what we're calculating in this example, then it just says that the interest that gets combined together inside the parentheses there is for the first and the second year. Okay, now you may remember this problem from the in-class exercise on Wednesday, and this is one that I wish that we'd had more time to take a look at, but we solved it two different ways. There was the approach where you moved each year individually from the time in which it appeared to year 4. And let me see if I can just pull open the sketch that I had showed you for that, because I think it is this one? Yeah. Okay, so that first part of the example, you may remember that I gave a label to each one of those arrows, and that was because I hoped that the label would help to make it clear how many years into the future each of those individual amounts was being compounded. And so like arrow A had to move 1, 2, 3 years into the future to get to year 4. And so that's why we did n equals 3 in that. And then arrow B only had to move 2 years, and so on. So that was one approach, is we treated each one of those arrows as a single future value that we were compounding to the future. The other approach that we took in that example was using this equation where this is f divided by a. And with that formula found the same 53,876. Okay, so let's just see if we applied these new ideas of compounding, then would we be able to calculate the same value for f? So what I mean is, if we were going to put it as a table and figure out for each row how much interest is accumulating and the cumulative interest that continues to compound, if we go year by year, this 12,500 is the amount that you're withdrawing. And in the end, at year 4, you're having to make a deposit that's economically equivalent. So what you can think of this as is that during 4 years, you're taking withdrawals and you have to find the equivalent deposit in the 4th year. So the 12,500 that you take in year 1, you'll notice it's at the end of the first year, so that's why we have year 0 is blank, is year 0 refers to the beginning of the first year. So it's at the end of the first year that that amount is taken. And so what's going to be subject to 5% interest during the next period is just the 12,500 that we've taken so far. And so now at the end of the period, it's going to be $625 of interest if this is 5% interest that's due. And so this table kind of sequentially shows at the beginning and the end of each period how much is cumulative been owed, the new amount that's taken, and then the combined amount that's applicable to the interest. So we're going to get into the details of Microsoft Excel a little bit later in the semester, but I just wanted to give you kind of this preview that it's another tool we're going to have at our disposal, is setting things up in spreadsheets. And once you got the formula set up nicely, the good thing about these spreadsheets is that you can replicate row by row really in a pretty straightforward way, where you don't have to type the formula in so many times because we're going to anchor our cell references. But that's just another method for solving these future values, is with the spreadsheet. So that's a preview of things to come. Now, our book introduces the difference between nominal interest and effective interest. And so nominal interest, one way that I like to help people remember that is nominal means not really. It's just a way of thinking of not really because, well, let me show you what I mean. Nominal interest is where the interest we know is going to be compounded more than once per year, but for whatever reason we're describing it on an annual basis. And banks are notorious for this, trying to blur the lines between reality and a more easily to advertise fiction. So let's say that a bank is claiming that the loan is 16% per year and that it's compounded quarterly. Compounded quarterly means that every 3 months, or 4 times per year, they're going to calculate the balance of your loan. And then during the next period, you have to pay interest on the previously calculated balance. And so what it works out to is that you're paying 4% per period, but it's not really 16% per year when you take the effect of compounding into account. So nominally means not really 16%, because if you're paying 4% per period, it's going to be more than 16% per year on an effective basis. And so effective interest is when you are accounting for the added expense of compounding during a year. So 4% per period, when it's compounding 4 times per year, will have an effective interest rate greater than 16%, because this is the formula we use to calculate the effective interest rate. Now, the variables here are the nominal interest rate per year. And so in this example of 16%, what we would say for R is 0.16. I think Seth has it right. I don't have the solution right there in front of me, but yeah, I think it is 16.98%. So you can follow along. Let's do that. I've got my calculator here. Do you have your calculator handy? So R is 0.16, so 0.16. M is 4, so 0.16 divided by 4, so that's 1.04. If we add together the 1 on the left side inside those brackets, so 1.04 to the power of 4, and then subtract 1. So yes, Seth had it right. 16.985% is the effective interest rate if it is compounding quarterly. All right. Now, in today's in-class exercise, let's see, here it is. We are going to get some practice with compounding and recognize its effects. And let's start off together, and then I'll put you into breakout groups for the last 3 problems. So we'll do the first 3 problems together, and then we'll go into the breakout groups for the last 3 problems. And all right, so problem 1 here. You're depositing $25,000 into an account. And remember my suggestion from before that when you get a problem statement like this, maybe write the variable right next to the number. Okay, so you deposit $25,000 into an account. Now it doesn't specifically say it in this statement, but you're depositing it now at time 0. It didn't say at time 0, but it's implied, and you need to infer that it's at the present. Okay, so that means this is P, 25,000. The account pays 6.5% per year, compounded annually. Okay, so sometimes if it's compounded more than once per year, then the interest rate per period will be different from the interest rate per year. Like back to our prior example where I was 0.04, but here that isn't the case. Here I is 0.065. What is the balance? Okay, so interpreting that problem statement, that's telling us F equals question mark. in the account after 30 years. N equals 30. Okay, so find F in that example. And when you've got a guess, go ahead and put it in the chat box. Got some guesses there. Not guesses, calculations. Good. Let me pull up the solution here. That's not it. Gotta scroll quick so you can't see the rest of the solutions. All right. Oop, that's too much. 165,359.15 Good. All right. So both Nick and Cameron had it right. As a reminder, when we use these formulas, we need to be accurate to the nearest penny. So even though here I showed 6.6143, I should have maybe had like a ... after that to imply that I kept all the precision in my calculator. Like I didn't keep writing numbers just because I'm lazy and maybe I ran out of room on the page, but I still have all those digits in my calculator. I'm not rounding off until at the end of the problem I round off to the nearest penny. So I think I'll try and do that on future examples where I keep the precision just as an indicator. We'll use that notation of ... after I write some of the digits as an indicator that I haven't rounded off yet. Okay, so any questions about this first problem? By the way, I meant to mention earlier, I went through homework 0 submissions and I was really happy with the thoughtful responses that almost everybody provided. And there were 2 things in particular that I liked, and several people did this. You know how my question kind of asked, what grade do you want this semester? What's your goal as far as a grade? I was really pleased to see that several students said, well, I'd like to get an A, but more importantly, I want to learn the material. And I thought, wow, that's just the perfect response, that students are more focused on learning and less focused on the indicator of learning. So I liked that. Thumbs up. Well done. The other thing I wanted to compliment people on when it comes to the getting to know you type responses that was in homework 0 is I said, why is money important in your profession? Why is a course on money important, basically? And a lot of people said, for obvious reasons, like that projects cost money and you want to be a good steward for your employer's interests and that sort of thing. But several people mentioned, well, money's important and I hope to have a well-paying career, but money isn't everything and happiness is more important than dollars. And I also like to see that. I thought that reflected a really mature attitude about finances, because you can be rich and miserable, and plenty of people are. But when you've got problems, having a little money helps to solve them. Okay, so I just wanted to mention, by the way, I put in some comments and I graded that optional assignment homework 0, and so you may want to look in the grade book to see the comments that I provided. Glad I remembered to say that. All right, so problem 2. You need to have $95,000 available in 15 years. How much should you deposit now into a savings account that pays 4% per year compounded annually? It's going to be the same formula that applies. All right, let me pause for a moment, and you're going to be solving for P. When you've got your calculation, please type it into the chat bar. To the second one. Oh, all right, brain power. What am I doing here? Okay. Okay. 52,750 and 13 cents. All right, so you can see that I've identified F and N. Now sometimes these problems are going to be a little bit less explicit. Like for example, if the default assumption is annual compounding unless it says otherwise. So this problem statement could have said, how much should you deposit now in a savings account that pays 4%? And so period. What if the period was after 4%? It would be the same thing. Because per year is the default assumption for percentage. And then compounded annually is also the default assumption. So if I hadn't said per year and if I hadn't said compounded annually, it would be the same thing. And for that matter, I could have simplified the statement by just saying, how much should you deposit in a savings account? I don't have to tell you that it's now, because now, or times 0 in any financial transaction, is when the thing happens. And so, like how much you deposit now is kind of implied that, you know, when you do the deposit, that's times 0. So I just wanted to mention that because, you know, as the semester goes on, I'm going to be progressively less explicit, and I'm going to rely on you understanding those default assumptions, like that interest rate is by convention expressed on an annual basis. And you'll know that when I say how much should you deposit, that means it's going to be in the present, unless I say it otherwise. All right, question 3. You can choose between 2 savings accounts. Plan 1 offers 7.5 annual interest, compounded annually, and Plan 2 offers 7.25 annual interest, compounded monthly. If you plan to deposit $125,000 and save for 10 years, how much additional money will you earn by choosing the better of those 2 plans? All right, so what you need to do is calculate how much would you get if you put 125 into Plan 1? How much would you get if you put 125,000 into Plan 2? The difference between the two is going to be N and I. For Plan 1, I is 0.075 and N is 10. But for Plan 2, I will be this divided by 12, and N would be this times 12. So N means the number of periods, and if the periods are monthly, then there's going to be 120 of them during a 10-year period. All right, so let me pause for a second and give you the chance to calculate what will be the account balance for both of these plans. Okay, well, let's take a look and see where things are headed with this example. Okay. Plan 1 is pretty easy. With Plan 1, N is 10 and I is 0.075. So when we put it into that formula that's provided, the same one from above, then the amount is going to be $257,628. Now Plan 2 is just going to be a little bit different. It's not going to be a lot different because the interest rate is about the same. It's just that it's compounding monthly instead of annually. So if the interest rates are pretty close together, you shouldn't notice a huge difference between the additional that you're going to see. So N is 120. I is going to be the interest rate per year divided by 12, because what we need to know is what's the interest rate per period. So I in that formula that we're going to use, I means interest rate per period. It's just that most of the time a period and a year is the same thing. But in this instance, the period is months. Okay, so if you look, we're going to have this 1.00604,167. This is the interest rate per month, and then we take it to the power of 120, That means we're going to get 257,529. So plan one is better. It's a little bit better, not a lot better. $99.92. So it's a thing that you got to be on the lookout for, because once in a while I'm going to sneak it in there. I'm going to try and put it past you and see whether you notice the compounding frequency. So on these problem statements, you need to look real carefully, because if it says it's compounded anything other than annually, it is going to have an effect on the method that you follow. You're going to change n accordingly, and you also change I. It makes a difference. If you had n is 120, but then you kept the original I, then that would seem like a really juicy savings account. It would be basically telling you what's the balance after 120 years rather than after 120 months. Okay, so I'm going to put you in the breakout rooms now. Boy, I hope at this point that everybody has printed out the in-class exercises. And if not for the whole semester, hopefully you've got at least today's, because as soon as I put you in those breakout rooms, then you're not going to be able to see the remainder of the in-class exercise. And so for just a moment, let me get that up on the screen. I don't know if any of you are doing the print screen thing just so that you can capture what's on the screen. But okay, so here are the next three problems. When I put you in these breakout rooms, one other suggestion besides, collaborate to figure out the answer to this. Maybe introduce yourself to the group. If anybody's interested in exchanging like phone numbers or contact details so that you check the homework with each other. Like in the class, I do have a policy that you're not supposed to cheat, but I encourage students to check answers with each other. And so if you've got a buddy in the class that you can get together on Microsoft Teams or send a text message to and check an answer, and then if somebody is off, if your answers don't agree, you can find the mistake, that sort of thing. We're working remotely, most of us, and so it's hard to have that collaboration that would sometimes help with learning. So when I put you in the breakout rooms, feel free to be social, exchange contact details and all of that, Snapchat, whatever works, however you guys can get in touch with each other and then collaborate on these assignments. And I don't know if you've also heard about it, that there are virtual learning hubs on campus. I'll give you an announcement slide on Monday that talks about that. Maybe the grind of just being in your apartment or dorm or home without being on campus gets a little bit unbearable sometimes. There are a handful of centers on campus that are set up specifically for students to take their classes together. All right, I'm going to put you in the breakout rooms, and these are the next three problems we're working on. So I've heard the magic number is 5 students, so I'm going to see if I can get as close to that number. All right, here we go. See if your group was successful in calculating the answer. All right, question 4 is all about effective versus nominal interest rate. And so what you can see is that if it's quarterly interest, it goes from 24% per year nominally to an effective interest rate of 26.25. But the more often it's compounded, drives the interest rate up a little. So if it's daily compounding, for instance, then you'd find 24% on a nominal annual basis ends up being effective to 27.11%. So effective, what that means is an account that compounds once per year at 27.11% would be equivalent to that account that compounds daily when you're paying 24% nominal per year. So effective basically means is, if you were, instead of compounding the interest every single day, you could compound once per year, then you'd need to use the 27.1% for it to be effective. All right, thank you for confirming that I am being heard. I really heard today, guys. All right, so question 5 Cash flow diagram, don't solve the problem, just do the sketch. So this is what that sketch should look like. You'll notice that I didn't combine the individual F's with the applicable A's, and I also didn't find the net A. Like in this instance, I think it's a good habit to, if you've got both expenses and revenue in a year, keep them separate in the cash flow diagram, because it's possible that some assumption could change. You know, like you're going to need to maybe have the flexibility to now have different fuel costs. And so, you know, we could just change the label on that A, and suddenly now the cash flow diagram could represent adjusted fuel costs. So this is what I had in mind for the cash flow diagram. Now, what about this last problem, number 6? You're willing to loan $27,500. They're going to pay you back annual installments over a 15-year period at 9.5%. What's the payment amount? All right, so this formula that was on your page, it's a ratio, just like the others have been. It's A divided by P this is the right-hand side of the equation. So the left-hand side of the equation is A divided by P, which means if we're solving for the payment amount, we're trying to find the uniform annual amount, A, then we move the P over to the right-hand side of the equation and multiply it by whatever factor we calculate inside the brackets. And so the $27,500 means that if they're paying you that juicy 9.5% interest rate, you're going to get payments each year of $3,512.95. I would love to get a loan that's paying me back 9.5%. Maybe a little bit less thrilled if it was a startup company. But that's the numbers for this one. All right, everybody, that's it for today. If you have lingering questions about the answers from the previous homework assignment, or if you want to ask me about the next homework assignment, I wish we had more time that I could address that now for everybody. But if you do have a question, feel free to give me a call during my office hours. I'm going into another class right now at 1 o'clock, but I'll be here in my office starting at 2 through the rest of the afternoon. If you want to give me a call on Teams, I'd be glad to hear from you. That's it. Take care, everybody. See you next week.
Have a good weekend.
Thank you.